So some of the common degrees are like 2, 3, 4, 5, and 6. A degree 2 can look like that. A degree 3 can look like this or like this. A degree 4 can kind of look like a W for a degree 4. A degree 5 maybe like this or possibly like that. And then finally, a degree 6, maybe something like this. Now, a couple of things here. Notice that if you're even, 2, 4, 6, if you're even, then your arrows do the same thing, either both up or both down. So if I have a graph that looks something like this, I know the degree is going to be a number that is even because the arrows are both together. This also would be even because the arrows are together. They do the same thing, either both up or both down. Whereas odd, you have one of each, one down, one up, one down, one of each for odd. Now, what about the idea of positive or negative? For the idea of positive, negative, the only thing you look at is the right arrow. Look at the right arrow. You see the right. If the right arrow goes up, 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 you have positive orientation. This whole upper row of graphs is positive orientation. The bottom row is all negative, because if you look at the right arrow, they all go down. You don't look at the left arrow for positive, negative. No. You only look at the right arrow. If it goes up, you have positive. If it goes down, you have negative orientation. Let's see, what about the idea of real? For example, let's say I go here. Can we agree that this picture is a function that has a degree of 3? Okay. However, I only have one real root. A real root is like an x-intercept, basically. When it crosses the x-axis, that's called a real root. So if I have one real root and my degree is 3, that implies that I have two roots that are not real. And if they're not real, we call them imaginary. So real plus imaginary has to equal the degree. For example, how about this picture here? Let's say something like this here. How about something like this? So can we agree? No, just kidding. How about something like this? There we go. That's what I want. So the degree here, what would be the degree? So was it 5? Here's another little quick lesson. How can I find the degree by looking at a picture? Like, that's obvious, that's 2 and that's 3. But this picture here, the heck is the degree? So here's one thing that you can do. Count the number of turns. Look, you know how you went down then up? That means that you have a turn. You see up here how you go up, then you go down? That means that you have a turn. Here is a turn, here is a turn. This picture has 4 turns. And if you go turns and if you add 1, that gives you the degree. So this degree is 5. For example, think of something that you're convinced of. Think of, like, let's say a parabola. A parabola has 1 turn. So you go 1 and you always just add 1, and that gives you 2, which is your degree. So you always count the number of turns. So this one had 4 turns, and always go plus 1, and that tells you your degree. So anyways, as we were, this guy, it has a degree of 5. But how many are real roots? Real root, real root, real root. So I have 3 real roots, which implies that I have 2 roots that are imaginary.